Hi everyone, this is Dhanasekaran, Assistant Professor, Department of Electronics and Communication Engineering, KS Rangasamy College of Technology. Today we going to see about the convolution integral in the model name of time domain analysis of linear time invariant systems in the course name of signals and system. So before we going to start the convolution integral, we should know about what is convolution integral. Convolution integral that express the amount of overlap of one function with another. It is defined as the integral of product of two function after one is reflected about the y-axis and shifted. The overlap between the two function can be evaluated by convolution integral. So which is a generalized product of two function. When one of the function is reversed and that function will be shifted, the convolution of two functions produces a separate third function that describes how the first function modifies the second one. So this is the convolution integral, and the operation that combines two signal to produce the third signal. So it is a fundamental tool used to compute the response of the continuous time linear invariant system to an arbitrary input signal. Mathematically, that the convolution integral expressed as y of t is equal to minus infinity to plus infinity x of tau h of t minus tau into d tau. So when recalling this convolution operation, so we'll have v of t and w of t, that's the two function. So we can denote it as v of t into w of t, or sometimes v into w of t. So we get v of t into w of t is equal to minus integral of minus infinity to plus infinity v of tau into w of t minus tau into d tau. So we have a different discrete time cases for the convolution operation, commutative and associative distributive. These laws are combined, we get the impulse response of an linear time invariant system in the unit impulse. The system is identity system. This is expressed in the x of t integral of minus infinity to plus infinity x of tau del of t minus tau into d tau. So the convolution integral is very similar to the calculation of convolution sum. So this is evaluated by the equation y of t minus integral of minus infinity plus infinity x of tau h of t minus tau into d tau. So this is the example one. We'll have h of tau as the indicated in the below figure. That is a sketch of h of t minus tau for t is equal to minus 2 and t is equal to plus 2. So as we already said, we going to shift and reverse one of the function, and the convolution of two function produce the separate third function that describes how the first function modifies the second one. And this is the time reversed impulse response shifted to the left, and the second image is the time impulse response shifted to the right. So in the left we have h of minus 2 minus tau, in the right h of 2 minus tau. So the example 2, we have the impulse response and input signal to be convoluted. That is the response h of t is equal to u of t plus 1, and the x of t is equal to minus e to the power of 2 of t minus 1 u of minus t minus 1. So we're going to sketch the impulse response, that is h of tau and x of tau. So this is a time reversed impulse response, that is a time reversed impulse response, and the time reversed impulse response shifted to the left, and time reversed impulse response shifted to the right. So one is h of minus tau, and the shifted left is h of t minus tau for the time interval of t less than minus 1, and time reverse impulse response shifted to the right, h of t minus tau for the t greater than equal to 0. And in continuing the example 2, so we'll get y of t is equal to minus 1 by 2 e to the power of 2t into u of minus t minus 1 by 2 into u of t. So overall response of the LTI system has the sum of two signal, that is minus 1 by 2 e to the power of 2 into u of t and plus minus 2 into u of t. So these two combines will get the y of t. And coming to the end of the session, we have to know about the application of convolution integral. So there are plenty of application in the convolution integral. So the probability, statics, acoustic, and the computer vision and differential equation. Thank you for watching. Thank you.